How do we graph parametric equations by evaluating? There are other methods of graphing parametric equations, but this is going to be the simplest one, although not always the fastest. So to graph parametric equations by evaluation, you're going to first identify what is the parameter. Usually it's t, but sometimes it could be another variable. It could be theta is the second most common parameter. Create a table with the parameter as input values. Evaluate the parametric equations to find the output values. And then graph the output coordinates and label the orientation is optional but desirable. So we're going to identify, create, evaluate, and then graph. So let us first identify the parameter as t. I'm going to create a table using t as the input, x and y as the output. Feels like a good choice would be to use multiples of, like pieces of pi, like pi over 2, pi over 4. Let's go with 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm choosing these just because this is cosine and sine. So let's plug in 0. We plug in 0, we get out 1, so times 5 is 5. Plug in pi over 2, we get out 0. Plug in pi, we get out -5. Plug in 3 pi over 2, we get out 0. Plug in 2 pi, we get out 5. Y, when we plug in 0, we get out 0. When we plug in pi over 2, we get out 1 times 3. Then we plug in pi, we get out 0. Plug in 3 pi over 2, we get out -1 times 3. Plug in 2 pi and we get out 0 again. So now let's plot these points. And the order of these points does matter as t increases is what we care about. So we're going to look at, even though this was our input, we're going to look at this set of data points. So I'm first going to plot 5, 0. Then I'm going to plot 0, 3. Then I'm going to plot -5, 0. Then I'm going to plot 0, -3. And then I'm going to plot 5, 0. So what we saw was there was this pattern going on. And it actually describes an ellipse. We've just finished step 4. What we talk about with the orientation is the fact that we were going from 5, 0 to 0, 3. So if we put an arrow on this, we show which direction we were going. And that does matter occasionally to describe which direction the parametric equation is going in. All right, the variable, once again, is t. So we're going to create a table with t, x, and y. Let's plug in 0, 1, 2. We'll find out afterward if we need to plug in more points. So plug in 0, we get out -5. Plug in 1, we get out -3. Plug in 2, we get out -1. Plugging in 0 here, we get out -4. Plugging in 1, we get out 0. Plugging in 2, we get out 4. So now let's plot these points. We have -5, -4, -3, 0, and -1, 4. So this appears to be our parametric graph. And note that I'm going to put the arrow in that direction, showing which direction we're going in. We can put more than one arrow on the graph. Typically, one is enough. So this is linear. Here we have t as our parameter again. So let's create t, x, and y. Let's plug in, because we know we're going to be squaring this and then dividing by 2, let's plug in some even numbers. When we plug in 0, we get out 0. Plug in 2, we get out 2. Plug in 4, we get out 8. For y, when we plug in 0, we get out 0, 2, and 4. So let's see what we get. 0, 0, 2, 2, 8, 4. So it appears that what we're getting is a parabola. And that makes sense because one of these is squared and the other one is not. And this is the direction of the parabola. If we plug in a negative, what happens actually? So if we plug in a negative, if we plug in -2 as our t value, we get -2 squared is 4, and then 4 over 2 is 2, and then this will become -2. So it is true that we will get out the bottom half of the parabola as well, but it is clear that it's coming in from this side and then out in the quadrant 1.